So today I didn't really have any specific topics I wanted to talk about, but I do have the AI running, so let me get that up on the screen. And so I just wanted to go over what I've been working on with the AI. So as you know, with the original AI, with just the genetic, purely genetic algorithm, it was successful in figuring out the simpler equation. And so I've since tried to make improvements to that in order to upgrade the speed at which the AI would converge on the answer. And none of these have been successful with the simpler equation. Now, this does lead me to believe that this may have been a fluke that the original one got to the answer as quick as it did, but I am testing around with the idea that these improvements may not be effective on simpler tasks and so this was something we saw when deep learning was implemented with the ball drop task. That task was so simple that the stripped down AI was actually faster at getting to an answer because it had less to worry about each individual generation. So I'm actually testing the improved AI with the more complex equation. Now, this complex equation is not the same as the one I showed you. It is relatively similar, but it is not exactly the same. So I'm going to go ahead and open up the picture of the equation here and just show you what I did. So you can see the equation on the screen now, or at least you should be able to. And what I've done is I've taken the denominator and removed it. So now just the numerator is the equation. And the reason I did this is because the answers that were that came out of this equation with the denominator included were so variable that the AI could not even try to learn. So what I mean by that is that some of the answers were less than 1 but greater than 0, so they were small fractions, and some of them were to the magnitude of 10 to the power of 100 and higher. And so whenever the AI would test an equation, it would get back a least squared regression of over the size of a possible number Python is willing to use, which is somewhere over the order of 10 to the 300 power. So I had some little bits of code here and there to try and remedy that, but I decided that I shouldn't try to have that as my benchmark. I should try and do one step up from what I had previously done. So this is still a relatively complex equation. There's some constants in there which haven't been seen before. There's some power functions. There's some sinusoidal functions. So this is going to be a lot harder for the AI to figure out. Now, you can see that the AI is currently running right now, and it is 60 generations in. The score is pretty arbitrary right now because this is something that the previous running with the simpler equation that had achieved just with a completely wrong answer. So the AI can get lucky and still have that answer. So I want to look at what the equation is right now. And so on the 59th generation, it upgraded to have the equation of x variable 4 as the answer. So right now it hasn't really learned anything, but that number has gotten a little bit whittled down. And also there's some, I believe there's some variables on the deep list. Oh, okay, so there isn't. I was going to say, because there are some equations that have popped up, like there's this one that's x variable 2 plus x variable 3. And I know you can't see this right now. I don't have it up on the screen, but I'll just explain it. So the previous generation before this had x variable 2 plus x variable 3 as its second, and so there were other equations that were slightly complex that have been added in throughout this, but the actual improvement has not been seen. So this is because the score is not whittled down enough to where the AI gets desperate. Although it did just reset, so I'm not sure. I do want to let this run out to at least 100 generations just to see if it makes any improvement. But it is something that takes time because there are a lot of statistics, there are a lot of probabilities in play here, and it is possible that a particular run could go on forever, even though almost every other run would be successful. So this is something that I need to try and run more often. And I also want to go back, and I know I've been talking about this, but I want to go back and I want to rerun the initial test to see if I can replicate the results. Because that's something that's just a good practice to get in the habit of. And I want to make sure that I'm not on a wild goose chase here, and maybe I should go back to the drawing board altogether. But I don't know, we'll see. So as of right now, I have this running, and so it will be running in the background of the stream for the remainder of the stream. I want to see what I have for the improvements. So the most recent improvements that I have made is that it now kills the second parent at 10 generations as opposed to 20 generations of being stuck on the same parents. That's just something I decided would be an improvement because of the other improvement I made, which is the randomized stuck reset. So when the AI was stuck before, the AI would reset the second parent back to the original null character, the null value. And so that meant that the AI wasn't having any possibility of improvement from this reset. So what I wanted to do is just have a random chance of improvement from the reset. And so what I did is it creates a random new element which can be compound when it resets. And so that's what actually happened with that recent change, with that recent reset in the current running that we're seeing right now. Like I said, on the 58th generation, it had a variable that was compound, and I believe that is because it was following the initial variable that was put in place by the reset. So that is basically what has been going on. There were some other minor changes. I realized that my dominance score, which if you go way back to when I was talking about how the AI actually decides how variables are transferred to the next generation, the dominance score is essentially the score that is it's deciding how favored the best score is to the second best score. And it's pretty simple. It was just the best score over the best score plus the second best score. And that would give a probability. And I realized that this was not the way that it works for this individual run, for this individual project, because a smaller score is better. So I wanted it to favor the best score even though it was smaller. So what I did was I took that fraction and I replaced the numerator with the second best score as opposed to the best score, just so that the bigger of the two, the bigger probability was in favor of the best score. So that's a pretty simple change, but it was something that needed to be done because it was affecting the overall efficiency of the program, or at least it should have been. Also, you'll see these errors popping up. These were errors that were occurring that I just told the AI to kind of um, not necessarily ignore, but what happens is if these errors pop up, it would just say that that test was equal to the greatest possible amount of points. And the reason for that is because these errors have to do with creating answers that were complex numbers, so having imaginary numbers, and also creating equations that would receive a score that was too big for Python to handle. So this just meant that I just set it to a relatively high score so that it wouldn't even be considered, and it moved on. This saves some efficiency as opposed to trying to dig through those equations and find the small, minute piece of useful information. Also, you will notice that the mutation percentage is I'm not sure if I explained that, so I'm just going to explain it right now. So what this percentage is actually the probability that the AI will mutate at any given circumstance. So if it's looking at a particular element in the equation and it's trying to decide whether it should mutate that element, that number you're seeing is the percentage chance that it has to mutate. And so that that percentage actually goes down every time it successfully upgrades the score. And when the parent is killed, when the second parent is killed and reset, then that score doubles or goes back to 100, whichever one is lower. Because I didn't want it to go higher than 100, because then it would be stuck at essentially 100% for a very long time. And so that was the initial way it worked. It would just double, but I recently fixed that so that it would only go up to 100, which is why you're not seeing some crazy decimal. So what happens is every time that the AI successfully improves, the percentage chance of mutating is decreased by 9% of the total percentage left. So that's a percent of a percent, I know, but just imagine we had the number 81 right now. So, okay, so the previous number was 90. What is 9% of 90? That's 9. So it took the, so it took the, or you can think, what's 10% of 90? So I messed up when I was explaining it. So what's 10% of 90? Because it's saving 90% of the final answer. So if you had 100 and you subtracted 10%, you get 90. If you have 90 and you subtract 10%, you get 81, which is where we are right now. So that's how it's working. And so that 90% is just an arbitrary number. I might fiddle around with it, but the idea is that it's supposed to be something that would slowly converge to 0, but never get there. So in a case that it was close to the answer, odds are it's going to get stuck a lot and it will bump back up, but that just promotes more change so that it can figure out what that last step is. And so if the AI is improving a lot, then it has a lot more pieces to work with. And so I decided that it was important for the AI to look at the pieces that it has already and focus on organizing them in the correct orientation, as opposed to creating new pieces. This is so that it doesn't get too watered down, because if something important is created, I don't want it to lose the possibility of putting that in the right place of the equation. So this is similar to how the optimizer actually worked. It's just a little bit more dynamic as opposed to analog. So the optimizer in the ball drop program would, in the event that the AI was stuck for a long period of time, the optimizer would take a look at the if statements that were there and see if reordering them would improve the program. So this, in a sense, is the opposite logic, but the same result, or at least what I'm going for. So when the AI is not stuck, when the AI has learned a lot, then it has a lot more at its disposal that it hasn't necessarily figured out the exact spot that it needs to go. Or maybe a new deep variable is something that could be used in many different places. So what it does is, as opposed to mutating, it has now a lower chance of mutating. Now, 81% is still a pretty high chance, but that percentage continually goes down and down and down and down until it gets very small. And so there's always going to be some chance of mutating, but at the same time, the focus is put more on using its assets as efficient as possible. And so that is a pretty big change that I've made. I'm actually calling this running Datamine 3.1. 3.0 was the initial change to have this dynamic mutation factor, and but I immediately tried it on the simple equation, and it actually got relatively close. I'm gonna pull that up just to have a reference for it. So the equation it got to was variable 3 plus the quantity of variable 2 times variable 4. So this variable 2 times variable 4 is a good piece, because the actual answer was completely multiplied by variable 4 and involved variable 2 and variable 3. So it was going along the right track, but this was at generation 162, and it actually made this improvement way back at, I'm looking for it, generation 52. So it was kind of stuck, and I couldn't really figure out what the problem was, but this is something I'm going to toy around with in the days to come. And so this obviously is going to be a long process in order to get an efficient program that actually runs smooth and fast. But I believe that I'm on the right track. So that's pretty much all I wanted to talk about today in terms of the data mining project. I don't have any other specific topics I wanted to talk about today, simply because I couldn't think of any, and I didn't want to force anything out. I just want to keep these streams relatively smooth, which is something I haven't been doing in the past. I want to work better on my transitions and whatnot. So, speaking of transitions, if there are no questions in the chat that you would like me to answer, I'm going to move on to my other section, which is my random drawing section. But if you do have any questions while I'm doing the random drawing, please leave them in the chat, and I will look at them after the drawing and possibly be able to answer them before I sign off the stream. But I'm going to give it a couple seconds so I can get things set up, and then I will move on to my next section. So bear with me.